Well, maybe we'll start because I think we have more than a quorum here, and I'd like to thank everybody for attending. This is in regard to well 16B 7832, and this will be a drilling well on paper, or I guess in this case, a drilling well on PowerPoint. We'll try and keep this as informal as possible, and it is going to be relatively high level. If you have questions, either put them in the chat, or if they're for clarification, just go ahead and unmute yourself and ask the question. So, as context, and you know, there are many people on this call who are not necessarily familiar with Forge, who are out of the country or participating outside of it. I just need to acknowledge that this is a Department of Energy project, and there are many stakeholders that are supporting the DOE in this project, particularly Smithfield, Utah School and Institutional Trust Lands Administration, which is known as SITLA, Beaver County, the Governor's Office of Economic Development, and Utah's congressional delegation. And I'm just a logistician in this respect, and there's many people in the background that have really helped in designing this program and will continue to do so. So let's first set the stage a little bit. And some of you, particularly the stat people, have seen some of these slides, but I think it's important that everyone knows that this is not a well where ROP is the number one consideration. We've got a number of goals, and the first is to provide a second well that's part of a doublet to well 16A. So if you can see the aerial photograph on the left, or excuse me, on the right, you can see 16A was drilled to a total depth of just under 11,000 feet, and it has a little over 4,000 feet of lateral drilled to 15.
I don't think it came up on our
John,
screen,
yeah,
John.
we're not seeing your presentation, John. We're seeing the slide in working mode.
Okay, let's try this
There you
again.
John, I see the field map, the drone.
Full screen?
No.
Okay. So now
I
you
see
got
it in the
you just got to
notes.
go display
Oh.
settings and swap it.
Yeah.
Next one over. Display settings
To the
to the right.
to the right under the little arrow
Right
on
there you go.
display.
Then swap. There you go. Now
There you
got it.
go.
Well, now I can't see it, guys. So, but that's okay. No problem.
Oh,
Well, thank you. So we're off to a great start.
I can let you know.
Anyways, so what we've got, as you can see from the illustration on the right, is 16A was drilled to a measured depth of just under 11,000 feet, 4,000 foot of lateral at a 65-degree angle to the vertical. And the goal of the 16B well is to parallel that well. Is to parallel that well and be 300 feet vertically above it, so that we have the second half of this doublet. We have an injector and a producer, and we're going to frack between them. So that's the primary objective of this well, so that we can establish that we can connect with hydraulic fractures. The overriding objective of all of this needs to be safe operations, and that's safe on location. We have a site manager online, Garth Larson, and we're welcoming anybody to visit, but just please coordinate with us in advance, and Garth will provide indoctrination on location. There will also be a check-in station. It's sort of a relic from COVID, but it worked pretty well, and we still will require PCR tests, but they're non-invasive, and they'll take you 5 minutes. On top of this, we have an overriding traffic light system that applies to all drilling and completion operations on this well. And I won't necessarily go through it in detail, but it is logically based on seismic methodology, and we will be monitoring events from our surface nodes. Okay, so as I said, the second well will be 300 feet vertically above the first well. And so what you see in this illustration is the blue line is the original well that was drilled, known as 16A colloquially. The gray section at the end of that well is 200 feet of open hole. And you can see microseismicity that denotes the growth of 3 hydraulic fractures that were pumped last April. The magenta line is the ideal or nominal trajectory of the well that we're going to talk about today. And that well is going to twin this well, be 300 feet higher. It will have a build angle of 5.5 degrees per 100. It will be drilled nominally at 65 degrees, and it will be drilled north 105 east. Now, in addition to actually creating the second half of the doublet, we want to improve the quality of the well that we drilled. And here are some images from an SPE paper by Fred Dupriest and Sam Neuner that were based on UBI images that we took in this particular well. And you can see that each one of these is a 10-foot long section for an 8.5-inch diameter hole, or maybe it was 8 3/4. I don't completely recall. And you can see that there's a fair bit of roughness in these holes, and that roughness could potentially have implications. We're running 3 fiber optic strings in this new well, so we really want to do our best to eliminate this rugosity. And so we're going to try and do this by bit design, by monitoring MSE to reduce dysfunctions, progressively modifying the BHA, and we will use rotary steerable in the 9.5-inch hole size. Also, this well is going to be heavily logged and heavily monitored. We will have sensors in the bits, one on the center line and one in the shank, and those sensors will be used to detect standard bottom hole parameters as well as higher frequency signals, so that we can particularly try and understand the HFTOs that may have been an issue in past drilling, and certainly are an issue in any drilling in this type of rock, where we're really putting a significant amount of weight on bit. We will also be running 3 fiber optic strings, and those strings are being run courtesy of 2 independent organizations that have research awards through the FORGE program, and those are the University of Texas and Rice University. And those universities are further interacting with Shell via University of Texas and Silixa via Rice University to run 3 fiber optic strings. 2 strings to the shoe of the 7-inch, and 1 string with a PT gauge to somewhere in the heel of the well. And so this is going to be quite a dainty operation, because these can be, it's fragile, but a lot of planning has started, and a lot more is going on. There will be a separate IWOP for instrumented well on paper that will happen. And so these instrumentation protocols are being developed by Shell and Silixa and emplaced. The wellhead is being manufactured by Streamflow with specifications from the fiber optics companies, allowing exit of these fiber optics through the top of the hanger. And our gratitude in terms of the well design goes to Mark Voigt with Fervo, who has really provided tremendous insight and support to us. And the cable protection and design is under the supervision of Alan Reynolds with Shell. So this is going to be a significant operation with these cables. In addition to that, you'll hear today from Mark Kelly from Battelle. Battelle and Baker will be carrying out an in situ microhydraulic fracturing stress measurement campaign. And we will also be measuring, and Mark will discuss that later on in this presentation. And also online is Matthew Ingram from Sandia, and Matthew will be doing analytic strain recovery measurements on core that is recovered from this well. So what you can see is that we have optical measurements for strain, temperature, seismicity, pressure, and we have physical in situ measurements for stress, and core-based measurements for stress and other mechanical properties and geologic characterization. And so just in terms of that, Canamera will be coring this well, and we will do 2 sections of coring. The first section will be a vertical segment of 2 30-foot runs just below the intermediate casing. And then we will drill ahead and we'll take this well to 500 feet, about 500 feet from TD. And then we'll do strategic core runs to try and intersect where the hydraulic fractures from the 16A well have been cut by this well. And so hopefully we can recover that. And so 2 campaigns of coring, 1 vertical and 1 in the and 1 major campaign in the slant hole. Also, a lot of logging runs that will go on. You know, we'll log the intermediate cement job. We'll log the build separately. We'll log halfway through the lateral, and we'll log significantly at TD. And I'll talk a little bit more about some of the logging specifics later on. And then will be a significant campaign of circulating fluid in these wells to identify connectivity of the fractures. And so also, on going back to this one, you can see at the right, as you may recall, we ran discrete tracers in each of the 3 stages of the fracs that were done at the toe of well 16A. And so we'll be monitoring for those tracers, and we also pumped a little bit of micropropant in the 3rd stage, and we'll be looking for that as well. And in terms of doing that, that brings up that XLOG will be doing the mud logging. I'm pleased to see them on the call this morning. And during this part of the job, we'll all be pretty busy capturing samples, because it is very, very important for us to try and determine the extent, the connectivity, and the characteristics of the intersections of these hydraulic fractures from the previous well. And then, as I said, on top of that, and I'll talk about it, we will be doing 3 injection circulation type tests to assess this connectivity in a physical fashion. So let's just sort of recap. You know, this is not this well is designed to, you know, really go ahead and help us de-risk some technologies, and that includes EGS in itself, and it includes technologies that are ancillary but necessary for EGS, and this includes improved drilling, different types of drilling, etc. And so in that spirit, we will be doing a short section of particle drilling, and we'll let Tony Pink maybe describe some of that when he's able to get online. We're also looking at extensive bit monitoring, particularly HFTOs. We are using basic PDC designs from what we learned on the previous wells with some modifications. And of course, this is a slightly larger hole size, so they're all brand new bits, but we're excited in the PDC bit design. And at the present time, we will be using bits from NOV and from Baker. And we've been working with these folks for some months as it is. Coring, rotary steerable, SDI, Scientific Drilling, will be the directional contractor. And as we go through this, I'm going to ask Chandler Smith to maybe narrate the individual BHAs when we come to them. 3 cables as described, and we will all be paying significantly more attention to cementing in these wells. It seems like cementing has been something that has given us a bit of problem in the past, and we really want to pay attention to doing this. And in fact, one of the only things that's hanging over our head at the present time is coming up with float equipment for these wells. We're working through some contractual issues. Stress measurements, logging, circulation, and there's some other tool testing, drilling fluids and BHA modifications that I really can't talk about today, but these are being finalized and negotiated. And the reason that those are so important is that this really cuts to the chase in terms of what Forge is all about. It's about providing a methodology and a location for testing out new technologies, new tools, and we're really excited about the opportunities for doing that. So that was a somewhat of a long-winded introduction and familiar to many people online, but there are many people that do not know the background of Forge. So let's just get there now. Okay. So how long is this going to take? Well, we think it's just under 100 days. Not so much for drilling, but as I said, there's a lot of tripping out of the hole to do specific logging, to do specific measurements. There's going to be a lot of conditioning this hole in terms of gauge runs and clean out. Our experience in 16A found that there was a lot of residual cuttings that we needed to make multiple runs to get out, and we want to do our best to work out some of that roughness. First of all, not create as much, and secondly, to be able to work some of it out and ensure that we can get all the fiber optics safely to bottom and cemented in place. So a little more specifically, for those people that are trying to plan their summers, here is an anticipated schedule, and as you know, these schedules, well, they will change, but they'll be approximate. There's some things here that I'd like to tweak myself in terms of reducing a number of days, but I've just held off. But Frontier Drilling will be providing rig 16, and I have to say we've just had fantastic interaction over the past few years with Frontier in terms of providing the rigs to do activities on this location and the crews. So they'll move in about April 15th, and it's anticipated that we'll be ready to spud about April 21st. But that won't happen because there are 2 days of formal training that all hands need to go through. And this training is led by Professor Fred Dupriest and Professor Sam Neuner from Texas A&M University. And they'll be talking about physics-based drilling. And I don't know whether either one of those fellows are online. If they are, I'd be happy for you to just describe briefly what you'll cover in those 2 days. So those two gentlemen are known for being very brief.
Yeah.
Oh,
there's
Sam.
Sam.
Here. I didn't have
there's-
my button pushed here, John.
Okay.
There's Sam as well. We're the physics-based drilling is part of the DOE funded grant Sam and I have to work with the geothermal industry in general, and Forge has been incredibly generous and a great place to have experimented with those workflows and processes, and I think they've contributed a lot to the gain. You've made the point that ROP is not the objective, and it's actually never exactly our objective. It's just a metric. We want smooth hull, but everything we do to increase ROP tends to increase the smoothness of the hull, and that's not obvious, but it's largely about vibration. So there's a lot of vibration management, a lot of basic physics, things that the crew can't implement very well if they don't physically understand some things differently than what the industry generally knows. And so that's what we'll try to set them up in the first 2 days to be able to do things, including smooth hull, cool life, low vibrations, get a hole we can get packers in and out of, all that stuff. It's all part of the same understanding how things work. That's how you get there.
Thank you, Fred. And so 2 days of training, and I think that we can all attest to the fact that this training has been very successful in terms of things that have happened at Forge, in terms of enfranchising the entire rig crew, consultants, and everyone in the process, and it really led to some spectacular successes that we hope to continue. So that'll take 2 days. We'll run surface, or we'll drill surface. We'll cement. We'll drill the intermediate. We'll drill ahead 10 feet and do an extended leak-off test, and I'll cover this a little further as we go along. But for people to sort of get an idea of the timeline, you can see that Battelle is scheduled for 10 days, sometimes towards the end of June. After Battelle is done, we'll be running the fiber optics and the casing. So the Shell folks and the Rice folks, happy 4th of July. And the circulation testing will happen subsequent to that, plus or minus. Okay, so let's get down to a few more nuts and bolts. As you recall, this well is in central Utah. I'm not going to go through the details. It's in Milford, about 170 miles south of Salt Lake. But what's more important is the figure on the right is that it is a conductive thermal environment, and we're dealing with static bottom hole temperatures that will be on the order of 430 degrees Fahrenheit. That to manage that, we are using specialized tools, and we're also using 3 chillers, courtesy of Drill Cool, who has been awarded the contract for the chillers. So what does this look like? So if you're looking at what's happening during the drilling, you can see from, let's look at the illustration in the middle, that you've got the green granitic hard rock, and it's overlain by alluvium that has been shed by the mountains to the east. And that alluvium is moderately to sometimes weakly consolidated. And so what that implies is that we will not be logging the alluvium, and we haven't in the past. We will drill surface to get through an aquifer that kind of exists in non-potable water at about 700 feet ground level. We'll set surface at 1,100 feet. We'll drill ahead to intermediate 400 feet into the granite. So something into the granite. I don't know whether you can see my cursor because I don't know what screen I'm pointing at, but it's okay. And then we'll drill ahead a little bit in the production hole, and then start to build. So to summarize this, and for people that want some sort of idea of what the geologic situation looks like, here are 3 panels that show, the left-hand panel shows where things stood last March. The middle panel shows 3 stimulations at the toe of the inclined well done last April. And the dotted line in the right-hand panel shows the planned well to intersect these fractures. And this is, as I said, this is a real goal of this well, is to intersect and characterize these fracture openings. And so you can see that although it's nominally homogeneous, you can see that there are variations in this so-called granitoid, that you've got more shearing towards the top. You've got a granitic-like rock in the middle reaches, and down along the toe you have a little more metamorphosed granitoid, and it's expressed sometimes as a gneissic rock. So this will be the 7th well that we've drilled here. It's drilled from the same pad that the 16A well was drilled from. Actually drilled with the same rig, Frontier Rig 16, shown drilling the earlier well. And there's a fair bit of geologic context that we've acquired over time in this area. So it's a large pad. It's a very nice pad, actually. We have not finalized all locations, but for the vendors, looking at where they're going to be. If there's still uncertainty, contact myself or Clay Jones. Clay will be on I'm sure Clay is on the phone call today. But basically, the drill site managers will be at this in this location here, and we have actually we have a permanent portable trailer for them, and so if anybody has uncertainty in terms of where they need to spot their trailers or equipment, please contact Clay and myself, and we'll sort that out. We still have a little work to do in terms of finalizing where we're going to locate the fiber optics trailers as drilling goes on, and ultimately the permanent location of those instrumentation trailers. But we'll work through that with the rig and the instrumentation folks. So that's the background and the context. What will we actually be doing? We have pipe on location, courtesy of Tubular, and this is the plan. The conductor pipe, it was going to be drilled yesterday, but we've had a bit of snow, and so that's going to happen in the next little while. As soon as the conductor pipe is drilled, we'll have scientific drilling repeat their trajectory analysis, but I don't think it's going to differ too much from what they've done for us already. The reason to be repeated is we'll have this physically surveyed rather than just relying on GPS. So conductor pipe, the surface shoe will be set at 1,100 feet. And so, as I said, that's sort of beyond where this aquifer kind of exists. We never know, how intense that's going to be. It'll be 16-inch JFE 110. It'll be a 22-inch hole, 84-pound per foot casing. And after the surface hole, we'll drill that out with 14 3/4-inch hole, and we'll drill that to 4960 feet, which is penetrating about 400 or 500 feet into this granite, and then set 11 3/4-inch JFE 110. And you'll notice that there's some mixtures of pipes here, and this is mainly because of availability of casing, and sometimes we had to take what we could get as long as the specs were in excess of what we needed. We'll drill out of the intermediate shoe with a 9.5-inch bit. We'll do an extended leak-off test. Then we'll core ahead 60 feet. Then we'll do some particle drilling for about 500 odd feet, and as I said, we'll have Tony Ping from NOV describe that, and then we will go back in the hole with SDI's rotary steerable system, drill ahead to the build at 5.5 degrees, and land the lateral at about 6,938 feet, drill ahead to TD. We're going to leave about 500 feet of this well open, and we'll discuss that later on. So, any questions up to this point? Okay. So Wyoming Casing will be installing the conductor pipe and the mouse hole. And that'll happen any day now, weather permitting. And then Frontier will drill ahead with the 22-inch hole to 1,100 feet, and I pretty much described that already. Schlumberger has the contract for cementing coming out of Bakersfield, and Calvin is on the line. Thank you, Calvin. And we're just finalizing the PO on that and going through working on the design for all of the cementing stages in this particular well. So we'll install a casing head via stream flow, and we'll pressure test that, and we'll nipple up 21.25-inch BOP. The bid is out on that. It'll either be 2,000 or 3,000 psi, depending on what we can get. At this point, I'm gonna ask my colleagues from SDI, particularly Chandler, to maybe describe his BHA, and then after that, I have a slide where I'm gonna ask John Tuttle from Sinclair Services to talk about the mud systems. So Chandler, I saw you were on. Could you unmute and maybe describe what you're going to use in the surface hole here?
Yeah, good morning, everybody. So our plan here is a 22-inch bit. We'll have the SDI 9.15 mud motor, and it will have an 1/8 under lower gauge, lower bearing stabilizer, plus a 1/8 under stabilizer above the motor. We were planning on using our 9.5-inch EM MWD tool to record surveys and deviation as we drill. So we'll have, before we're ready to case, we'll be all set up with good documentation of as where we're at. So nothing too sophisticated. A float will be in the string above the motor, and we'll run some, decent weight. We'll have possibly 6 to 9 8-inch drill collars up above that will cross over to above our 9.5-inch non-mag material. That was the 22-inch hole, John.
Thank you. John Tuttle, do you want to talk about the mud system? John, I've broken up this in terms of surface intermediate and production hole, and maybe we'll just start with the surface.
Yeah, fair enough. Good morning, everybody. So we've done all the wells out there at Forge. So this system is pretty consistent with what we've done recently, did on 16A. So pretty simple, just getting hole stability for the surface, a couple of intervals. Just freshwater flocculated system, a little bit of fluid loss control, but good rheology to clean the hole through the first interval and just get that casing in the ground. So pretty straightforward there. We haven't really encountered any severe loss circulation, but we have a decision tree for that if it's encountered. So keep it simple on the surface hole.
Thank you, John. Okay, so we have the surface hole. As I said, Schlumberger has a preliminary design for submitting that hole, and we'll refine that design over the next few weeks before we spud. After waiting on cement, we will drill out the 16-inch casing, and we'll do formation integrity test, probably 9.6 pounds per gallon. And we'll likely drill it out with a roller cone bit, and then maybe well, I guess there's more to come on that. But Chandler, why don't you go first and just talk about your BHA for this section of hole? So this section of hole will go to 4,960 feet, which is about 400 feet below the granite contact, so that we're beyond this sheared zone. We've got enough casing that we can play with that a little bit, but we don't want to go too much deeper before we go to 9.5-inch hole.
Okay, I know we'll make a short particle drilling tool run ahead of picking this BHA up. Oh no, that's next step. Anyway, the 14 3/4 inch BHA will be similar to the 22-inch BHA with both 1/8 inch under stabilization. The only thing we're going to do different here is go ahead, because we're going down to give or take 4,900 foot, is put a 1.5 degree fixed bent housing motor in here just in case we need to make some light nudges to keep this thing on track, because that's a pretty long way to go without any control. So that was our plan there. Same basic EM system, 9.5-inch in, like I say, 1/8 inch under, stay below and above. The motor also will have the 8-inch drill collars crossed over from the 9.5-inch tools in the spring, but that's the main, just one small difference in this BHA, still 1/8 inch under and obviously 14 3/4 inch PDC bit.
John.
I believe it's a PDC bit. I'm making sure that was correct. I think
it is, yes. So as you can see, we'll drill out the shoe with a tricone, and then we'll run PDC. Now I'm not sure who's on from NOV. Matt, are you on by any chance?
Yes, sir.
Do you want to say a couple of words about these two bits?
Yeah, the TKC 66 is a proven bit in this formation. So that one was easy. The A4, and then the 83 was designed specifically for this well to drill the granite.
Cool. John, do you want anything different about the mud here that you want to add?
No, we'll just modify it for slightly higher temperatures and any modifications needed for the coring intervals. And if we get into competent rock and it's appropriate, that we can roll towards water, watering back the system. But that should be determined by wellbore stability and other requirements for the project through this interval. But basically, just carry forward of the initial whole interval fluid and tighten it up some.
So you're mentioning drilling with water, and I might just ask Fred to step in here and talk about previous experience in drilling with water in these wells. I'm catching people off guard.
Phenomena that develops under the bed is it creating a granular material. It doesn't create cuttings. It creates just this granular mass of material ahead of the cutter. Pressure drops, it gets strong, blah, blah. It's some physics to that, but it makes already filled granular material under the cutter really strong, which reduces our ROP. And we were running about half the ROP as when we use water. Water penetrates that granular material really quickly. So water is proved to double our ROP on the last well. And we can see that with specific energy and all kinds of things that prove the physics of what's going on. We'll want water, and we don't want molecules that viscosify that water, and we don't need them in this well. Most likely, we don't, probably, and we'll see how that goes. The particle drilling requires high viscosity, so that'll be a different interval there where we have to lift those little steel balls out, tiny particles. But when we finish that interval, we'll need to get back to pure water if we can, and certainly we can vertical, and probably can in a higher angle as well with the flow rates and all that we have. We'll see how that goes. So we may experiment with a few pills to see if we can get something faster than water with some surfactant or something that would get the water in that granular material faster to relieve its low internal pressure, pressurize it, and get it out of there. We'll see how that goes, and we're still poking around on ideas about how to get it faster than water. Again, let's come back to ROP is not the objective. We can tell if those things are working with MSC, looking at mechanical specific energy. So it won't affect the well if we circulate 100 barrels through and do a few of these kinds of experiments, but it can have a huge effect on the entire geothermal industry if we can continue to demonstrate more of the physics and practices that will make granite drill faster in wells where we do want that.
Thank you. So that hole's drilled. We'll run the wellhead equipment, standard operations. Once again, big thanks out to Mark White with Fervo helping us through some of these aspects here. There may be some slight changes in this. We're discussing with Frontier about bringing out a 5K 13 and 5/8 BOPE equipment rather than 10K. So now comes the really interesting part, that we'll drill out that shoe with a 9.5 inch bit, and we will drill ahead 10 feet and do an extended leak-off test. We still have RFPs out for low-pressure pumping equipment to be able to do this. And so I don't know who the vendor for that is going to be. But for example, Bill Rickard has done this on previous wells, and I think it's really a good idea to do it at this point in this particular well, to duplicate what GRG has done previously and just see how the stresses look. So we'll do the extended leak off test, and then we will core ahead. As I said, that we'll core ahead 60 feet, and Canamera will be doing the coring. I'm not sure if Blake or Galena are online, but if they are, you may want to say a few words.
Hey, good morning. This is Scott Lukash. I'm not sure if Blake is actually on. He was
Okay, Scott.
he was finishing up on another call. So you have myself and Tim Gallagher from the operations side on. I'm not sure exactly what you'd like us to.
No, it's okay. I think the key things to talk about here are, first of all, your beefed up core catcher. That's one of the lessons that we learned from previous coring here, that we don't want to leave stubs of granite in the well. And then you'll be again running your non-jammer, which helped previously. And so beyond, and I think, are you using NOV bits or what will you be using? Do you know?
Yes, that's the plan as of right now. I think we have 2 bits ready to go, outfitted, and then, like you said, it'd be the anti-jam system for 2 30-foot runs in this section.
In this section, okay, thanks. So and then once this core is recovered, we're planning on having it extruded at the surface, and then Dr. Ingram from Sandia will be doing some anelastic strain recovery measurements. And Matthew, do you want to say just briefly what this entails?
Sure. So essentially what we're doing for the anelastic strain recovery is looking at how the rock relaxes as it's removed from the earth. So the most critical part is getting our hands on it as soon as we can once it's out of the ground. Then we'll instrument it, and I'll transport the core back to Albuquerque where we'll sort of watch it recover over time, and then use that and some lab testing to determine stress state.
Perfect. And then in the next couple of weeks, we will be coordinating, so the Canamera folks and yourself and Forge in the rig, we'll have an additional meeting just to coordinate protocol.
Sounds good.
Okay, so we'll core this section, the 60-foot section, and then we're going to try something that's kind of exciting, and this is particle drilling. And I'm not sure, Tony.
Yeah, I'm here, John, and I've got John Schiller and Alan in the background as well.
So I'm gonna show you this slide. So these guys haven't seen these slides, and I'm going to show you the next slide.
Okay.
So this is what you can talk about.
So I'll start with this one, and then just to give Alan and John a heads up, they can talk about the rig up and how to tie everything into the rig. So to everybody on the call, great to be here. It's a fantastic opportunity that the John and the team have given us here to have a couple of extra runs on a technology that is new, but it's not. We're not talking scientific breakthrough here. We're talking engineering iteration. Yeah. So the bit you see on the right, we are going to pump 2 millimeter shot. We're going to inject it into the wellbore. In between the pumps and the top drive, and we're going to pump 3% steel shot down the hole. That steel shot comes into those 4 nozzles that you can see in the nose of the bit, and that's going to blast about an 8 3/4 inch hole. Yeah. So the impact of those pellets, 12 million a minute. Will break up the granite in rocks that we tested in Central Texas that were considerably harder than the gray granite in Forge. We were getting ROPs in the range of 50 foot an hour. We're looking at, and John's expectation of us is that we're going to do something in the 100 plus feet per hour, and we really hope we're going to do that. So the particles will cut an 8 3/4 inch hole, and then the diamond you see on the bit then reams the hole. So luckily in this, we can actually save a run as well, because this bit is actually a reamer. Yeah. So we're going to be able to run in after the core run and ream the hole. So we will drill down the 60 foot of core run, and then when we get to, and we won't do that with injecting pellets. Then when we tag bottom, we'll pick up, and then we'll enable the particles to go around the system. And I'll let the guys explain that process in a bit more detail. And then we will, as we ramp up to the particles, we will then drill that section with particles. And what we're going to do is the way we drill ahead with this is we're going to slowly increase the weight that is on the reamer until we see a point where we touch the bottom of the hole with the nose of the bit, and we'll see a drop in torque. So that gives us the sort of point to understand where our sort of maximum ROP is at that stage. And then we will back off ever so slightly from that. We're hoping that's around 100, 120 feet an hour. And then we will steadily drill using the auto driller down through that vertical section. The BHA that we're putting in the hole is a packed assembly. The nature of drilling with particles and reaming the hole, we anticipate that to be pretty well dead straight. It has a natural tendency to drop anyway, so we're going to hopefully drill a dead straight borehole. But we'll have Scientific's EM tool in there, which has no moving parts in it behind us, so we can monitor the surveys and make sure that the well inclination is not getting away from us. And as we drill each stand down, we'll then pick up off bottom. We then circulate and lift the shot clear of the bottom of the hole, take a survey, make a connection, and then go back to drilling. So each time we'll space out the shot so that we we don't build up a wad of shot on the bottom of the hole. And then we'll drill the section that we've got down to kickoff. And then after we've done that, we'll evaluate the performance of it. How did it hold inclination? What was the ROP? And did we meet the expectations of the project? And then take a look at it at more detail. So next slide, please, John.
So maybe before we go there, let's just talk about two things that are bulleted on this slide. Is that we will be swapping out the mud, and I might ask John Tuttle to talk about what he has in mind to get the 16 yield point.
Yeah, John Tuttle here. So, pardon me, just seeing this the last couple of days, my thought is we'll be with fresh water at this point anyway. Pardon me. But so basically we're just talking about viscosifying this, but we're going to have to maintain not only yield point, but also gel strengths to keep these the shots suspended during any downtime. If you think we're going to be going 100 feet per hour, I mean, we're only looking maybe 6 to 8 hours with connection time for this 500-foot interval.
That would be fantastic, John. Yeah.
Okay.
And
So,
then,
go
sorry, go ahead. No, please.
I was just going to say, my initial run at this is to utilize, freshwater bentonite API gel to get the rheology required. We'll have to be a little bit careful based on the downhole temperatures so we don't end up with a lot of flocculation. But for this short of an interval and this short of a period of time, we shouldn't see any major aspects or challenges with getting a 16 yield point, which will also give us some fluid loss and some resistance on bottom, but that's the purpose of the shot, I guess. So anyway, basically just going back to the bentonite system, very, very similar to what we had on the surface, to be honest, with just bentonite.
Yeah, and then and Tony has explained to me, and I've asked him about this before, that you can see that this bit is made for reaming, and so we have an 8 3/4 inch core hole that this will pass through before it starts drilling ahead.
Yeah.
One thing for maybe John and Tony to address is the question from Robert at Chevron is how do we make sure that we have the particles out of the hole before we drill ahead? And you know, I have an observation there too.
So Alan or John, do you want to add to that?
Yeah, this is John. So a 16 yield point is pretty good anyway. And so you're talking about 12 million shots circulated per minute, right? 3%, and they're 2 millimeter. I'll play around with some stuff, some lifting, slip velocities and stuff like that. But basically that's pretty small. So if we can't, I mean, if to gain more comfort, we may want to run a couple of sweeps through there just to ensure that mechanically everything's up to instead of just rheology. So mechanical sweep would be something like our Ultivert product or even sawdust or condensate holes, mechanical lifting. So that's my initial thought anyway, unless you guys have some experience that shows that maybe there's some other approaches.
Yeah. So Alan Carson and John Schiller, would you like to add to that from past experience? You are muted, guys. Yeah.
We can address it. It is an important concern. We do have, you know, a roller cone bit that we'll probably use to drill out the shoe and drill ahead for the extended leak off test. Yes.
Alan, John?
Yes.
We're on the Polycom for audio, and I don't know why it won't talk to you, but we're on the computer now. And we were saying, yes, that's typically what we would do. Is, you know, the YP will clean most of it out, and then we'll pump a sweep and get the rest of it, and then we'll send a tool in to clean out any crevices down around the BOP.
Okay. Okay.
Hey, Johnny, this is John Schiller. Are you going to have a slide in a minute that shows what you're planning to do for the overall mud in this section of the hole, starting with the core?
I can't remember. We'll find out. But if not, John Tuttle. John, why don't you just, John Tuttle, why don't you just address that right now?
Yeah, so what was the question again? I'm sorry, you were breaking up.
Mud for this, you know, reiterate what the mud for this section of the hole is and what the mud is for drilling ahead.
Oh, okay. So,
I wanted
yeah.
to start with what the mud is for the core hole itself, actually.
So the core hole up above, if we maintain stability, then we'll be on water. You know, as long as the well bore stability is good up in the shallower intervals of that prior interval. But in the 9.5 production hole, we should be water until we get to this requirement for the particle drilling. Then we'll mud up, you know, basically just take the existing system, add bentonite and maybe a little bit of xanthan gum. It won't hold up probably to the temperatures for long, but it'll help give us some rheology that won't give us any high temperature gelation like bentonite will over an extended period of time. So basically we'll take water, convert it to just a gel water system for the particle drilling. And then once that's over, I recommend displacing the entire hole back to fresh water so we can go on with our drilling and monitoring our MSE and spurt loss and the like.
What yield point are you using when you drill the core hole?
It'll be minimal with water. So
you're swapping over from the core to start with from what you drilled your intermediate hole with.
right. Well, when we get to the bottom, near the bottom or into this stable granite in the intermediate hole, the thought is what we've done is transition towards water, and that's either a lot of dilution, utilizing the existing SCE, clean it out to water and just continue on with water and sweeps drilling ahead. So that would be utilized for the coring application as well. Now, if we have wellbore stability up hole through that interval, then we'll have to all discuss that and identify whether we go all the way to water or we just maintain the existing kind of a clay-based system through that last casing string before we get to the 9.5. But hopefully by the time we get in into the serious granite will be on water and sweeps. Did that answer your question?
Yes.
Hey, one more quick update on that particular run and the fluids, and we had this discussion regarding the particle drilling system. Is at the end, before you switch back over to water, we're planning on, I believe NOV is going to have plenty of ditch magnets out there, but we want to make sure 100% that we get all of those beads out of that string before we go in with the RSS.
Right then, Alan, do you want to talk through the system?
Sure, but I have one quick question based on the slide before. What is the distance between A and B on surface?
175, 200 feet, something like that.
Okay. That was, it looks like typically where we would set up, but I guess you said talk to Clay about how things are going to be on the surface.
And we want to have Frontier participating in that call too. And so
Yeah, absolutely.
we can coordinate that, but I'll make a note of that we need to figure out that layout.
Yep. That's for a different call, but I just wanted to clarify that.
Yeah, Clay will coordinate, but let's all get together and make sure the rig is involved.
It's about 130 feet, by the way.
Oh, 130.
Okay.
So I'm normally off by a factor of 2.
Well, we may be able to squeeze in there. Typically, we try and take up about 100 by 100 little section. And you can go to the next slide. I didn't mean for you to have to go backwards, but
that's a good note.
So typically, that's not really where we would normally be set up. We'd be kind of on the top end of that picture on the other side of the catwalk, in close proximity to the shakers, which where we recover all of the shot, and access to the high pressure line after the pump before the rig, which is where we inject it. But those 3 components, they're modular. They're only connected by wires and hoses, so they can be moved around, and we can find a way to make them all fit in there. We just need to have a plan before we show up.
Okay.
But on the picture, go ahead.
No, Alan, I will coordinate a meeting next week.
Okay, that'd be great. What you see in the picture is most of our kit, the part that does all of the work. The trailer is what injects the particles into the flow stream. It does not create any pressure. It only uses what the pumps put out and meters the particles into the flow. There's 3 units on there, so there's redundancy. We can run on 2 and have one on standby, or if anything needs to be repaired. And then the one in the back with the little cement mixer on there, that is the recovery unit. So it separates the particles from cuttings and stores them and allows them to be re-injected. So we recover the shot and reuse it, and a particle will see work about 3 times a day.
Okay. Okay. And anything else the NOV people want to add before we move on?
Did we just lose Alan? He sounded like he was in mid-sentence.
No, that's
okay.
That was all for this slide. I don't know what's after it.
You want to quickly highlight to the team what you do at Connections, Alan?
Sure. So the software in the system is monitoring ROP. It's monitoring the depth, and it's monitoring the block position, and it calculates when we should stop injecting shot so that we continue to drill down to the connection point. And we're following the particles with clean fluid. When we get to the connection point, we'll stop, and as Tony said, we'll lift off the bottom a little bit, and we'll clear shot out of the bit and up in the BHA a little bit. and then turn off flow and make your connection. And then our only lag time is reintroducing particles from surface to bit.
So I've got a quick question. So the return flow coming out of the hole, does it go direct to you then, or over our existing shakers that are in the active system?
It goes across the rig shakers, and from there we'll go into a separation shaker where we separate the cuttings from the particles.
Okay, and that's with your unit then?
The rig shakers work exactly like they normally do. They separate all solids from a liquid, and then we handle the solid separation after that.
Okay, so we have to have the shakers fine enough for the 2 millimeter cut at least.
Yes, but they'll ride across a number 10. So
okay.
if you're running 10.
Yeah, I didn't have my screen comparison ahead of me. Okay, thank you.
Good questions. Yeah.
Any further questions or observations on this? Well, we can come back to. So after that, you know, we're
Oh, sorry, John. One other point. We're going to run black box drilling dynamics.
Oh yeah.
Into the assembly. Yeah.
Yeah, that's a good point, Tony. Thank you for reminding me.
Yeah. So we will have we'll be able to measure 3-axis vibration directly at the particle bit and temperature, and then we will be measuring downhole weight, downhole torque, downhole RPM, 3-axis vibration just in between the first 2 roller reamers. Yeah. So and then the analysis of that data will give us a good idea of the vibrational environment that we were living in, and we'll do some optimization testing so that we can see what parameters yielded the most stable drilling. Yeah. Thanks. Yeah.
Cool. So this slide is a little bit in flux. I mean, the tentative plan with the particle drilling is to leave SDI a little bit of room above where they start the build. I've left 50 feet. If that's not enough, we need to discuss that. Circulate out the hole. At some point, we'll run Schlumberger's isolation scanner, and I think if people have questions, Eric Bushard is likely on the call. He can answer those. And we may run a gyro survey at this point as well. But as we proceed ahead, and what we really want to see from this section is the hole quality and the straightness that has come about up to this point. So okay, well, this kind of covers that. We've got 50 feet for Chandler to get his tool lined out. If that's not enough, then we can definitely change that. And then we'll drill ahead on the build, and the current plan is 5.5 degrees per 100 with a kickoff point at 5,600, and the projected landing is at 6938 MD, and we'll hold azimuth at 105 degrees. Somewhere after the build, and we may drill ahead a little bit, but we'll want to run a UBI. And we really, as I said, this seems like an unnecessary logging run, but we're looking for 2 things. We're looking for wear on casing. We saw a little bit of wear last time, not much, but a little bit. And so we want to keep an eye on that. But in particularly, we want to see what the quality of the hole was in the build, and what the quality of the hole was from the particle drilling. And so we'll do that. Then we'll drill ahead to about halfway to depth, 81, 84 feet. I don't know where the 84 came from. It's about halfway, and we'll do another logging run to assess what's happened in the lateral up to that point. So now is where I'll ask Chandler if he might step in with something that's a little more interesting. Oh, I don't mean that. I mean where he talks about the RSS.
Well, good deal. Yes, we it's a little hard for me to read right here, but we are looking at the RSS assembly, 9.5-inch bit. And we also had put in a roller reamer in this assembly, full gauge, that I believe I'm going to call it red back if I have that correct, red bank, one of the two is going to provide. On the RSS, that's a 3-pad push the bit tool. We've done some modeling. I don't know if it's in this particular presentation, but we have reviewed it with the team from Forge, and it'll have its own measurement device fairly close to the bit. We can spin it quite rapidly. We did look at some potential motors and kind of came back to the original one that we had proposed with a 0.23 RPG system on it as far as the availability, but plus the more data on amount of runs, and it's been a little bit more of our workhorse. So we didn't find a good option to go with a faster motor at this point. Yeah, we also looked at, there's been some quite a bit of analysis done by Trey Smith, who's one of our application engineers, and we'll have basically we're lining up 4 of those RSS tools for 9.5-inch hole. Most of them will be what we call our stiff collar design. We may have one as a flex collar design as a backup in case we're not getting the build rates that we have modeled. And otherwise, we're looking at about 650 GPM type of a flow rate through this system, and we'll be capturing data at the surface. The tool does send most of the data up by a mud pulse telemetry. And that the comment earlier about making sure all the beads are out is it does have some power generator on board that has some magnets on it. So we'll want to be careful about what gets pumped down the hole. Otherwise, I think that's my main comments on it. We will be getting, good and quick data, rotating fairly, quickly here and putting somewhere on the neighborhood. We've looked and there's some other things beside. There's been some discussion around, possibly as much as 65K weight on bit. There's some review going on engineering, but it's not only the RSS, but the mud motor bearing specs also play into that. So we're in the up to around the 60K range on our spec right now, weight on bit. Can go up to 350 RPM depending on rotary table from the top drive. So those are my main comments.
Thank you, Chandler. John, would you like to share a little bit on the mud system, if I can just advance the slides?
Sure thing. So bottom interval, they be just fresh water continuous. We'll be trying to keep our solids as low as possible. I just did a real quick calculation, but even if there's 1% solids left that settles out in the bottom of this hole, that could be over 100 feet of fill on bottom. So just for reference, it doesn't take much to add up. So solids control equipment and dilution as needed to keep as fresh a water as possible, and clean the hole with xanthan gum and mechanical sweeps, as we have done before. We'll also be monitoring corrosion rates and doing spurt loss testing on a pretty regular basis as needed, and testing a couple of other items, probably lubricity items and a surfactant in particular that to be determined. But basically we're drilling with water and just sweeps to clean the hole.
Thanks, John. And so this is the bottom line. This is what we want to look like. I mean, the red is the 16A well, and geez, we got a nice smooth 16B well. That's and we're going to follow that track exactly. One thing, Chandler, you may have Daniel take another look at this. We want to be at least 300 feet above it, and this is I think a discussion that we want to have just in terms of the ellipses of uncertainty, and just see where we actually finally spot that well and see whether or not we want to tweak it a little bit.
No, and that's fair enough. And I actually want to involve one of our other guys on looking at a few things on the existing wellbore data as well, and loop you guys in on that when I have some chance to review that as well. And we'll tighten up and finalize this with your actual physical land survey folks get out there and
Yep.
for sure, apples to apples on the land surveying of the existing well and the new well location, so that we're really dialed in, that we're using the same quality of data on both locations is really key.
Well, the snow should melt eventually, and we'll get that survey done. And then, so back to where we were, we landed this at 69.38 thereabouts. We'll drill ahead halfway, run some logs, likely a UBI. We may try an FMI. I forget exactly what is in the program. Eric can correct me. Yeah, go ahead, Eric.
I think we have both, John, but the FMI was to look at the fracturing afterwards.
Certainly at TD, we'll run both the UBI and the FMI.
Right. We're flexible either way. So.
Okay. And then after that, we'll drill ahead to about 500 feet short of TD. And even a little before this, you'll see in an upcoming slide, we might try a core run, because we'll set 7-inch at about 10.215. But one of the fractures from the previous well may intersect the wellbore a little earlier than that. And so we're going to need to be watching out for that all along. I'm not sure we're going to lose a lot of fluid, but we certainly want to find these fractures if at all possible. And actually we'll come to that. And so we're going to be trying out two different bits in here. We'll try out one Baker Hughes bit. I don't know, Baxter, are you on the line, or one of your colleagues?
Yes, sir. Andy Polly with Baker Bits on from the engineering side. So we'll have a 406 option. It'll be 13 mil cutter, 6 blade, kind of some of our latest cutter technology and kind of our best foot forward for this application.
Okay, thank you. And Matt, do you want to talk about your bit?
Sure. The vertical tangent bit is very similar to what we ran in 10 5/8 on the last well. So 4 blades to center, 13 mil, total of 8 blades, similar back rakes. Also, we put 6-inch tapered gauge on that. And then the curve bit is more along the lines of what we did on the first well. The bits that built the best. So we went with 7 blades there. They are 13 mil. And on that one, we have a 4-inch tapered gauge.
Okay, thank you. And then at this point, we would be coring. At one time we considered coring the whole 500 feet to TD from the shoe, but we've sort of backed off on that, and we're going to look at 3 60-foot zones where we high grade those zones, and we hope we catch the zones where the fractures have intersected the well. And Rob Podgorny at Idaho National Lab and his colleague Hari have really done a great job in looking at the microseismic signals that were generated and trying to infer where those are going to hit. Now, depending on how this well drills, we may move the actual sections around somewhat on the fly. But as it stands now, based on the planned trajectory, we'll actually try something a little bit uphole to look for stage 3. So at about 9,880 feet. And, we'll drill 10 feet on either side of that interval, or core 10 feet on either side of that interval. And then the 2 other zones are going to be informally within closer, or in the open hole section of the wellbore. And so these depths will be decided on the fly, but they won't be too far off of this. I mean, we've probably got 20 meters of accuracy in the microseismicity. So at that point, we'll be at TD, and as I mentioned, Schlumberger has been awarded the logging contract, and we will be now. Correct me if I'm wrong, Eric. We'll run the UBI on a Petromech trolley, and
that's correct.
We will run the FMI and the quad combo on a through bit logging system, and maybe you could describe the through bit system. Maybe you could describe both of those systems to people.
Yeah, absolutely, absolutely. And Gabriel with Petromac is on the call as well today if has anything to add. But the ultrasonic borehole imager is going to give us the hole shape in the open hole as well as evaluate the drilling wear in the casing above. The Petromac trolleys will help us. The tool will kind of roll down the well. What we will need is the temperature limitation I have from that ultrasonic borehole imager is 350 Fahrenheit, 350, and we can run right up to that, but we will have to kind of chill the well before we do that run to get it as cool as we can. And then the next run after that ultrasonic borehole imager is everything's going to be run on ThruBit. And the way ThruBit works is we rig up a hang-off sub and a portal bit at the end of the drill pipe. We need everything in the drill assembly itself to rabbit to a minimum ID of 2 3/8 inches, which I think is no problem with this string. And then what we do is we convey the tool string down through the pipe out the end of the hang-off sub and the portal bit, and then we'll have you pull the drill pipe back out of the well. The advantage of ThruBit is you can continually circulate while we're pulling the tools out of the well. So we can circulate, of course, at the bit down hole. The opening on that bit is 2.36 square inches. So I think we had a rate of about, I have to go back and confirm with my notes, but it was about 180 gallons a minute or so circulating when we logged on the 16A well. But the ThruBit platform itself, our tool string will be about 137 foot long. The entire tool string has an OD of 2 1/8 inches. It includes an imager, a dipole sonic, will do the 3D far field processing, and then the triple combo log. And so basically we'll rig up the portal bit, the hang-off sub, send the pipe down to into the open hole. We'll make sure we've got a rat hole of at least 137 feet. Probably 200 feet would be more ideal just to be on the safe side. We deploy the tools via wireline. We will want the hole, we'll chill the well at TD before deploying the tools in the wireline. We'll try to get down to a temperature of around 280 if we can, Fahrenheit or close to it. We'll deploy the tools wireline, open all the calipers, make sure everything's functioning. We then disconnect the wireline and the tools are logged out of the well in a memory mode. And while we're logging out, the rig is free to circulate the pipe or circulate and then also rotate the pipe. And we'll log out at about 1,800 feet an hour or about 30 feet a minute. So it was kind of a quick high level, but
that's great. And if people are interested in following up, I can
yeah, just point them my way. So,
okay.
Thanks, John.
Because I guess we're running out of time as we would expect, even though we're at the bottom of the hole. So we got this hole, and we don't know how much cuttings are on the bottom of it. We don't know how rough this hole is, but we're going to be doing a bunch of gauge runs and sweeps, and we still haven't finalized what this BHA is going to look like and what sort of reamers will be on it, et cetera, et cetera. But there's going to be a fair bit of work cleaning out that hole. Once that hole is cleaned out to the best of our ability, Battelle and Baker will be doing some in situ stress measurements. And Mark Kelly has provided me a number of slides. And Mark, I'll advance those slides at your discretion.
Okay, can you hear me okay?
Yes, indeed.
Great. Okay, so yeah, the objective here is to make a series of in situ measurements of stress in this 9.5 inch open borehole so we can characterize the stress profile as a function of depth. Next slide, please. And let's see. Okay, this just restates the objective that I just said. Again, make a series of stress measurements at different depths in the borehole to characterize the stress profile. Next slide, please. We'll do this. Oh, this is just an image of the well that you've seen already, I think. The point here is that we'll be doing these tests in the 9.5 inch open borehole below the intermediate casing, but before the 7-inch casing is set. Okay, next slide. And the way we'll be characterizing the stress is by doing mini-frac tests. I think everybody's probably familiar with this, but in case you're not, a mini-frac test is simply we isolate a section of the borehole with a straddle packer, and we inject into that water at a low rate but a high pressure until we see the rock break, and then we stop and inject a little bit longer, and then stop injecting and watch the pressure decline. And we can observe a number of important parameters related to fracturing, like fracture breakdown pressure, propagation pressure, and shut-in pressure, and closure pressure. And then typically we'll repeat that injection fall-off cycle 2 or 3 times on the same interval after it's been isolated for corroboration of the data. One important point is we can, once these fractures are created, we can determine the orientation or the azimuth of the fractures by running logs, image logs, sonic logs in the borehole. So we'll plan on doing that both before and after the fracturing tests. Okay, next slide, please. So our approach for doing these mini-frac tests is John's already mentioned, we're going to be working with Baker Hughes. They have a straddle packer test that's sort of a self-sufficient test tool where we can isolate approximately 1 meter of the borehole, pump into that interval, measure rate, control rate, and measure pressure and temperature over time. And we'll be deploying this tool on pipe to minimize the risk of stuck tool since it's a deviated hole. You've already heard the issue is one of the issues here is high temperatures, so we'll have to conduct intermittent circulation between our tests to maintain the temperature below the upper limit of what the test tools can tolerate. Also, there's potential for this rock may require very high breakdown pressures. So in addition to the straddle packer tool, we'll have a sleeve packer on the tool string that has a higher differential pressure rating. So if we cannot break the rock with a straddle, we'll probably reposition the tool, try to do it with a sleeve packer. I think I've already said this last bullet. We'll run image logs and sonic logs both before and after the mini-frac test to image the newly created fractures. Okay, next slide. This is just a temperature plot from a number of wells. So this is real temperature data from the site. It shows that at the TD of this well, 16B well, temperature will probably be on the order of 430 degrees Fahrenheit. And as I said before, this is in excess of what the Baker tools can tolerate. So we'll be conducting intermittent circulation to cool down the borehole as we move through this test program. Okay, next slide. This is just a temperature profile showing what might happen downhole during a testing sequence. So you start off with bottom hole temperatures on the order of 430 degrees. Each one of these lines is a different depth, by the way. But you get cooling. This is a 16-hour circulation simulation at 485 gallons per minute. Then after that is done, you'll see the temperatures warm back. And after different time periods, I've got 20 hours, 26 hours, and 39 hours marked there. You'll see the temperatures reach the 350 degree mark, depending what depth you're at. So this is the kind of information that we use to plan our test, our sort of detailed test program. Okay, next slide. And what the test program will consist of basically is doing 5 runs, a baseline logging run before and after the mini-frac testing, and then a repeat logging run after the mini-frac test run's been done. So 2 logging runs, a baseline and a repeat, and then in between we'll do 3 runs to conduct the mini-frac tests at different depths in the borehole. The first one will be done at which is called descent 2 here, will be done in the vertical section of the borehole, so we can test our methodology for doing the mini-frac tests without being at a depth where the temperatures are going to be critical, above the limits of the tool. So that's sort of a safe area to work in, to work the bugs out of our system. And then descent 3 and 4 will be done deeper in the borehole. We won't test in the build section, but we will test below the build section. We hope to conduct up to 3 mini-frac test at 3 different depths in each of these descents. So that's 5 runs. So again, 2 logging runs and 3 mini-frac test runs. And in between each of those, or before each of those rather, we'll do a cooling run where we'll circulate in the borehole to cool down before we run our tools in the hole. Excuse me. Okay, next slide. This just summarizes what I just said. I think the red boxes illustrate the target test zones where we'll be doing our mini-frac test. Again, the first one is in the vertical section, and then you see 2 others at depth in the incline section of the hole. Okay, next slide. I think this is my last slide, but this talks about the test tools, the way the tools will be configured. There'll be 2 different configurations for the 5 runs. The logging runs will have 1 configuration. The mini-frac runs will have a second configuration. We will not have image log and mini-frac testing tools on the same string, so we'll have to do a separate run, after we do the mini-frac test. Okay, next slide.
I think this is your last one.
Is that it? Okay, that was it.
You want to wrap up, or is it any of the folks from Baker want to add anything? Okay. Okay,
I guess so.
Cool. So we'll rig down with this and come out of the hole, and then we're going to do it the first of our circulation tests. So we've got a drilled hole. It's open. We're suspecting that there are going to be hydraulic fractures opening this hole. We will have monitoring equipment on well 16A and 16B and offset wells, and we will bullhead fluid into 16A, which is the original well, and monitor production out of 16B. I might ask Rob Podgorny if he's on the line, and I think he is. If he might want to say a few words about the monitoring that is going to be in place.
Well, John, I was eating my lunch, so thanks for a little bit of warning. We're finalizing the system now, but essentially what we have so far are fairly high resolution pressure transducers that can go in all the deep wells, those that go to the reservoir depth. We'll monitor those right now, normally on like a 10-second interval. That includes the well of 16A, the offset well. So we'll be actually monitoring that one as well. These all have 15 PSI transducers in them. And then when we transition to doing some of the flow-through testing, we have some higher pressure rated transducers, at least for 16A and B, we'll be able to isolate the low pressure so we don't blow them up. But all these things then will be monitored, as I said, every 10 seconds, give or take. And we are working on a system right now to push that stuff so that it'll be live in real time, available on the web.
Thanks, Rob, and enjoy lunch.
Thanks, John. I'm going to make you pay for it. I'll next time I see you.
Oh, I'm sure of that. Anyways, but fundamentally, what you can see is that we're gonna rig up a low rate pump on 16A, the original well that has the fracs in it, and we're going to pump it into that well. We're just going to bullhead fluid down. We have a 5,000 psi wellhead on our surface equipment on 16B, so we will not exceed 5,000 psi at 16A. And fundamentally, and this is we're still working out the equipment. This is what it might look like. So if you start with 16A at the bottom, you can see pulling from 2 blue frac tanks. There's a logo of a low rate pump truck. That bid is out to see, or will be out soon to see what that is. We've been monitoring pressure, rate, and temperature. Going into 16A and bullheading into 16A, we will be able to bypass to the pit if necessary. That fluid will move through the rock to 16B, and you can see at 16B, we'll have wellhead equipment that are measuring pressure, rate, and temperature. We'll be able to apply a back pressure and there will be 2 frac tanks that will serve as separators, or at least that is the concept at the present time, and this will go to the pit. So if anybody has any design suggestions here, this would be greatly appreciated. Just contact us. That would be great. The injection program is pretty low rate. We'll just inject into 16A because we really don't, and we want to keep the rates low because we don't want to create new fracture area at this time. We just want to test the connectivity. And so remember, 16B is open. The entire well is open. 16A, the entire well is open. We're just bullheading fluid, and it can go into the open hole or stage 2 or stage 3 fractures. And we'll record it in 16B, and this is sort of the rate profile that we have conceived of. Looks like I've left off a line on this because there would be a 1 barrel a minute stage at the end of this. So after that is done, one of the tougher parts of this well comes into play, and so we're going to have to run casing in this well, and we're going to have 3 fiber optic strings that are in the well, so one of the challenges is that there's going to be 500 feet of open hole, and so how do we keep cement out of that open hole as we're cementing in the casing? And the original concept was to run sand, and we had a discussion with our stat, and the suggestion was to try and run a bentonite on top of some sort of viscosified fluid or something similar, possibly CPO-lite instead of bentonite. This is still not finalized. We're working on this with Fred DePriest and John Tuttle and with Kevin England from the Forge team. So basically, we will sort this out in the next little while, and that's one of the things that needs to be finalized. Even before we put that in the hole, and actually some of this is, it just came to me that this is out of order, is that we will do a dummy run. We will mock up running fiber into the hole, the terminations, and so we'll have the complete package and a few joints of casing that we are going to run in the hole, possibly with a sacrificial float, just so that we can make sure that we can get everything into place and see if we have to work at anything further. So there'll be a dummy run, then we will place the barrier, then we will go into a very complex procedure for running the casing and the fiber optics. There will be a separate IWOP instrumentation well on paper that will be happening in the next little while. And actually, the best way maybe to do this is to show the next slide and turn the mic over to Alan Reynolds with Shell, who will be supervising the installation of the fiber and the casing.
Thanks, John. Can everybody hear me?
Indeed.
Okay, so you've set me up for a good little talk here, John. Thank you very much. What I'd like to recap on a few things that you've said, that is hole condition. Hole condition is the success for an instrumented installation. Minimal dog legs, good clean hole, minimum ridges, and I know we've labored that point already, so I will not dig into too deeply. But for sure, drilling sets it up for failure and success. So let's focus on the successful side for running in instrumentation. Also, as John said, there will be more detailed instrumented well on paper, and indeed that will be a lot closer to installation and address in detail the step-by-step process for running in 2 optical lines from Shell and 1 optical line from Silixa. This is just a high level, just to give an outline. So yes, we will be installing 3 optical lines. They are robust when you handle them, and they can be handled firmly. But when dealing with drilling loads and forces, they are really delicate. So I need to be careful when running in hole. I've ran it over 30 of these systems so far and successfully. So there is a proven method that has developed over the years where we can get to TD with these kinds of systems. We will be running the hole from a spooling unit over a sheave, and actually 3 sheaves, 1 per cable, and they will be mounted close to the monkey board. And if you can, I don't know if you can see my pointer or not on the screen, probably not. But the middle top picture shows where the sheave is loaded, is located. The one to the left on top row shows you some slips with two fiber optic lines. These lines are slightly larger than the ones that we'll be running in, but there's only 2. We will be running in a 1/4 inch line in addition to this from Silixa. Going back to the bullet points, the running speed is going to be slow. This is a marathon, not a sprint, to get it to the bottom. We're looking at 5 joints per hour in the deviated section because we'll be putting on a lot more protections for later perforating. But in the vertical section, we can increase that rate probably to 10 joints per hour because there's a lot less protection going on, and we are not stopping for readings that we would typically do in the section that would be going into the lateral or deviated section. We do have special protectors for protecting the cable, and you can see poor picture to the right at the top row of the gentleman with the red coveralls. That is showing a centralizer below the collar and a cross coupling protector. And these are installed using the Canon protectors, and most people on this call would probably be familiar with those. And they would be installed at regular intervals. It is typical for us to garner support and help and involvement of all the people on the rig floor, if they're willing. There will be more people on the drill floor than normal. So we need to be aware of safety and trips and blocking the driller's view and things like that. And I understand the drill string will be laid down before running a hole casing. Teamwork and communication is key here because, yes, I've run in many of these systems as have Silixa. But that doesn't mean to say we know everything. If something looks odd or out of place, then we encourage feedback. There's something that may be a good suggestion. It can prevent damage, or it can improve the efficiency of the installation. So it's all teamwork and communication on the rig floor. The final point is when people are installing fiber, there's obviously a reticence and caution because it's the first time sometimes that they've dealt with it. But I've installed many systems, as so have Silixa, so we've got a lot of experience to share. And all of that will be laid out in probably a 2 or 3 hour long IWOP that will be in the not too distant future. I'm sure there are lots of questions, but or maybe not. Anyway, I've finished saying what I need to say, John.
Thank you, Alan. Thomas, do you or Jonathan, do you want to add anything to this?
I'm not sure if Silixa is on, but not a lot to add. The Rice Silixa team, Fogmore, is putting in the 1/4 inch fiber cable, which Alan mentioned, and it'll have a tight buffered single mode fiber for strain measurements, and then an interior FIMPed with high backscatter fiber for DAS and multi-mode for DTS. So we hope to use that DTS to help with the real-time monitoring of the cement job as well.
Okay, excellent. Thank you, Jonathan. That was
Thanks, Jonathan. Yeah, John. Yeah, I'm here like from Silixa, but yeah, nothing to add. Very clear and complete what they said.
Okay, and so if anybody on this group would like to participate in the IWOP, drop me a note and I'll make sure that happens. Now, you know, Alan could have gone on for quite some time about the terminations and the BHA at the bottom of the casing, and there's just a schematic here. We're not really showing where those terminations are, but what I would like to point out here is that we're including a Petroquip locating nipple, and this is in advance of testing out a product that is currently under design as part of one of the research programs. And I might just ask Robert Kuhn from Petroquip to say a couple of words if Robert is still online.
Yes. Can you hear me?
Sorry, that was my watch.
Can you hear me?
Yes.
Yeah. So we have a nipple, basically a landing profile that is 5 foot long that we will thread with the VAM prop. And for all intents and purposes, it will act like a 5 foot long piece of casing. It has an ID of, I'm looking at the print right now, just barely over drift, 5.9. So actually the drift is 5.625, but it's a polished section that we can set a lock in that we could then in the future isolate everything below it and frac above it. But since he's running this now, we can put it in and use it anytime in the future. And you can cement through it. It's not going to hurt it and it's not going to stick to it. So it acts just like a 5 foot pup.
Cool. And you know, we don't know when we'll deploy Robert's device, but this is there for when we do want to test it. And so it was a good opportunity to run this. At the right, I would like to point out the wellhead that Streamflow is and Mark Voigt had designed with input from both Shell and Silixa. I think the interesting part is just the hanger here and the exit ports for the fiber optic strings. A really nice piece of design. So we've got, and I skipped over the cementing. You know, it's going to be a big deal too, and there's going to be a lot of work with Schlumberger to refine the cementing in this, and that will happen in the next 6 weeks or so. So at that point, we've got pipe cemented in the hole. We'll go in and we'll drill out the shoe, and we were originally going to use a 5 3/4 inch bit, but now that Petroquip is running their sub, we've got a little bit of a restriction there, so we'll use a 5 1/2 inch bit. And this, Alan reminded me I need to move laying down the drill pipe earlier. But we'll go in, we'll drill out the shoe, go in and circulate whatever material we have below the shoe. As I said, that's still being refined. We'll run some sort of a bond log, some sort of a gyro, and we will not log to determine the location of fiber optics at the present time. We will do that sometime in the future. But what we've got now is that we've got an open hole, and we're pretty certain that 2 of the fracture stages have intersected this open hole. So now we'll repeat the previous circulation test to see what happens in the open hole alone. And we also have fiber optics in the well. So if some of that fluid moves up and around the wellbore but doesn't penetrate the wellbore, we'll see that. Which reminds me, the fiber optics will all be active during the cementing. And so we'll be able to monitor the cementing exceptionally well. But basically, the program here is to pump the same injection as what was shown before, missing one line here at the bottom at 1 barrel a minute, and just see how it differs from the previous injection where there was a potential to go into 3 zones. Well, what happens if we don't have any connectivity? Well, I wish I could give you a detailed protocol, but this will kind of happen on the fly. If we decide that we need to actually inject into 16B, we'll have some low rate equipment on location. If we need to bring out higher rate equipment, that decision will be made at that particular time too. Hopefully we will not need to do this, but it's something that we want to conceive and consider it in further has ID conversations that we're having with the DSMs. And I need to mention the 4 DSMs on this well. The DSMs are going to be Brian Gresham, Leroy Swearingen, Randy Baldwin, and Gary Hedden, guys with a lot of experience. And so we're really in good hands. And then I think this may be close to the final slide. We'll release the rig, or likely release the rig, and then do it's nominally a 93-hour injection, getting up to 10 barrels a minute, shutting in for 24 hours, and then repeating that in stages. So Karen has suggested going to 20 barrels a minute, but that probably has to apply to the previous slide. If we got an obstruction, we may consider going higher. So what we've done here on this particular well is that ideally we've drilled the sister well, and we've established whether or not there's adequate connection. We have cables behind it that will support any sort of perforation that we might do in the future after we locate where those cables are. And the follow-on stage to this is sometime later in the year, early next year. There will be a fracture campaign as part of University of Texas's research program. We will do some additional stimulation in 16A and just see how those come to bear and encounter 16B. So this is a lot, and I really haven't been able to follow the chat. So I'm hoping all the questions are answered by some of my colleagues. But let's just open the floor to questions if in the last 10 minutes or so, or even better, let's open the floor to recommendations.
So John, this is Eric Upchurch at Chevron.
Hi, Eric.
Quick question about when we do the pump in test between the two wells. Are we going to have any kind of tools in either one of the wells to understand where a fluid's either exiting or entering?
Not at this point. So, okay. You know, in this, after we cement in fibers in the 16B well, we may be able to see if fluid is going through the third stage of the previous frac and coming up and cooling around the well, even if it doesn't intersect it. We don't know what the circulation is going to be, but at this point, we're just bullheading fluid into the first well, and we're just seeing that whether or not we're getting returns in the second. And what really the next stage and what the fiber is going to enable is it's really going to, once we do additional fracturing on the 16A well with the fiber in the 16B well, we'll really be able to tell what the intersections look like.
Okay, thanks.
Now, everything's just a matter of money. You know, if we had an intervention fiber optic cable that we could afford, we would not be opposed to deploying that in the 16B well while we were injecting into the 16A well. Just a DTS. But that's really not within the budget at the present time. So when we go back in the frac campaign, presumably that's something that we would like to, and this me is coming as a bit of a surprise to Joe, but I think being able to target where those injection points are in the 16B well might require an intervention cable to look at the open hole section. Hi, anyone else?
Yeah, John Tuttle here. Real quick question, rather mundane. Are you planning on having the two centrifuges for stripping like we did on the last well?
I'm going to have to confirm that with Frontier, but we have talked about centrifuges. Billy or Chris, do you happen to be on the line? Do you know what the status of that is? we'll find out.
Well,
There
we
will
can
be
take it offline. Okay.
Yeah.
Yeah, you'll need to work, this is Sam Norton, you'll need to, not all centrifuges are the same, right? And for this, it might not be the usual centrifuges you'd find on a drilling rig, because we're probably trying to strip out smaller particles than normal. So anyways, just something to, maybe John Tuttle or somebody can give some guidance on exact centrifuge requirements.
You got it. Sam, I'll visit with you afterwards. Okay.
Okay.
Yeah, if you would, and then we can bring in the rig as well. Because they are supplying that equipment. Anyone else? Well, we've got 10 minutes free so that everybody can stand and get their steps in that they've missed in the last 2 hours.
I guess one last question would be, the slides that we've seen here, are they going to be posted on the Forge website or what?
These slides are available. I don't know what the mechanism would be. Joe or I don't know whether Ghosh is on.
We'll figure out how to make them available.
Plus, this has, maybe unbeknownst to you, this has been recorded, and the recording will also be available, as well as the slides themselves.
John, maybe some of the cementing questions that we've got in terms of cementing equipment, just raise that again.
Well, I think we want to work with Schlumberger to finalize their PO and just make sure that all of those issues are. Yeah. This, so the one thing that's just sort of holding us back are high temperature float equipment. And if anybody has recommendations for vendors that might be able to supply that, we're having trouble. We have a contract in place that's under negotiation, but we're still having trouble. And if anybody has suggestions for sourcing high temperature floats and shoes, I would really appreciate hearing from you. Anyways, I'd like to thank everybody for their participation. I'm really excited about this. We got a fantastic team. If I've left anybody out, any of the vendors out, I apologize. I've tried to highlight everybody who's participating. If I've missed you, let me know. We really appreciate all of you. And so we'll send a note to the invitees of this as to how to, or we'll go from
John, I think we can go through the website on a wiki page, and we can post these on a wiki page probably a week or so.
Okay.
No later.
Okay. Okay.
So check our wiki page through our website.
Okay.
Hey, John, this is Kelly with Weatherford. Sorry, I'm a little late responding to this. Have you been talking to our folks about high temp cementation equipment with Weatherford? It's not my end of the business, so I'm not sure if we're involved in that. I can certainly check and see if we have anything available.
Yeah, well, why don't you go ahead and check? I mean, Weatherford did not respond to the original bid.
Okay.
But as I said, we continue to look. And so Kelly, if you can drop me a note about possibilities for something that can handle 430 Fahrenheit, we'd appreciate it.
All right, I'll do that. Thank you.
Thank you. Last chance. Okay, thanks everyone. We really appreciate your participation and everybody's support.
Ron? Thank you, John.
Yeah, thanks, John.
Thanks, John.
Good coverage. Appreciate it.
Yeah.
Thank you, John.
All right.
Well
thanks,
done.
guys.
you.
Hello, this is John.
Hey, John, this is Chris.
You're still on, John.
Yeah, you're muted.
A lot of other people that might be listening in, but I think they're all friends. So hey, I've got Joe Moore and Kevin England on the line as well. We just finished. So you didn't miss anything.
Well, I was on there.
Oh.
I couldn't get on there to go inside the center.
Yeah. So do we have two lined out? Is that, or were we only going to have one?
I think we only bid for one, but I don't know that.
So Joe, did you hear that?
No, I can't. I can't hear it.
One of the gentlemen said something about it needs to be a different kind of centrifuge. What we've done, talked with, is just the ones that they get reclaimed bar and stuff like that with. So if we need to do something different, I need to know so I can talk to them.
Yep. That's one of the things that we need to sort out. That's for sure. I don't know. Were there any other rig questions?
Did you see the answer to the pins, John?
The board is good for 5.5. 27 point, what is it? 27.9 FF?
24.7.
24.7.
You were close enough, but yeah, it looks like it's going to work.
Fingers are not big enough if you're going to run 5.5-inch spiral weight pipe.
Well, I don't know what we asked for.
So
go ahead, Kevin.
Well, I was gonna say, can Chris check on, I guess we thought it was well 58B32 that rig 16 drilled. They were possibly used the same size of 5.5 on that well.
Yeah. Well, were you guys able to hear?
I heard, but I think it was, which well, Kevin? It was 78B, not 58.
Well, it doesn't matter.
78B, yeah, 78B.
So what Chris was saying, and correct me if I'm wrong, Chris, you know, Chris, the easiest way to do this is just unmute yourself on the call. We're still on the call.
I don't know how to do that. Coming from another screen that I have no idea.
Okie dokie, we'll do it this way.
It's on the lower left. It'll say mute.
But Chris is phoning in, and so are you saying we can't run drill collars, or what are you saying? A heavyweight pipe?
We can, the 5.5-inch weight pipe, if it's spiral, it won't bigger than the regular weight.
I see. Okay. So the weight pipe can't be spiraled.
But it'll handle the 5.5-inch normal weight pipe should be 5.5 OD, just like your drill pipe. But the spiral, for some reason, is bigger.
Okay.
Okay.
So, Kevin, can you check on that?
Yeah, I think this is not spiral.
Yeah, we're going to double check on that.
Yeah,
but
that wasn't mentioned on the bid.
Yeah. Well, we'll just talk with the the potential vendor or the vendor.
Right.
So,
whoever's going to provide the weight pipe, they can tell us what it is.
Yep. That and maybe that's just a question to ask. We might have missed it on the bid.
That's okay. We'll ask.
Yeah.
So,
yeah, I'm pretty sure it's not spiral.
So, I think we need to have one other thing that's come to mind in the last little while is that we just need to confirm what sort of flow rates that you guys can get. You're going to be able to get the 900 without any trouble. Is that correct?
I got my flow chart in front of me with 6-inch liners at 120 strokes a minute. I can get 528 gallons per minute. That's at 100%. So, but where we're gonna be limited with that is we're gonna be limited to pressure. I don't know how much pressure we're anticipating to be pumping in beads and pumping all that other stuff.
Yeah. So is that, no, so I thought we had pumped higher than that before.
That's for the.
Is that per pump?
That's per pump.
Oh, guys, okay. And you're gonna have 3 pumps or 2?
3 pumps.
Yeah, okay. But then the other end of the spectrum are these guys that want you to pump at 200 gallons a minute.
And we can do that. You know, the other day I asked what they was gonna want, and we can do that. I got this flow chart, and they're 300 gallons a minute. We can do that with 1 pump.
Okay.
At the 50 strokes a minute.
Okay, that's awesome. Okay, so we're good there.
One thing I haven't received yet is, so I can kind of work on, is the shifts. Nobody sent me anything, a diagram or anything on them shifts, the 3 shifts.
Yeah, I'll have Alan call you because he's gonna want to talk about the shivs and the spreader bar.
Yeah, well, that's the assembly there that I'm talking
Okay.
about. So.
Yeah. Okay. I think he might have sent an email, but telephone is much better.
If he sent an email, I didn't read enough of it to make sense of it.
Yeah. Well, I'll prod him a little bit because that's kind of a critical element. That if you gotta start doing something, you want to be able to do it before you start rigging that thing up.
Yeah, we need to do it now instead of waiting and get the derrick in there and say, oh shit, we got to weld something in the derrick, lay it back over.
Yeah. That's I will contact him right away. Yeah. So I think everything is kind of falling together. We just need some cement floats, and hopefully we embarrassed Halliburton enough on this call that they're going to come through.
I sure hope so.
Anyways.
Let's see, were there any other chat questions that were
I don't know how to. So Chris, if you got anything else that stood out?
No, I think we're in good shape. I think we've covered what I was going to do, and if somebody will tell me what I need for that centrifuge, I will get with them guys and see what they've got and what they don't have.
Okay, will do.
So I got to know how many microns or whatever we're looking at kicking out.
Okay.
Whatever they're called. So.
Yeah. Gotcha. We'll find out the specs that they want.
Okay.
And Joe will smile as he changes the PO.
Absolutely. I've got permission to spend all the rest of our money.
Okay.
I need some new boots.
That one's going to be a little harder.
I don't want to know.
Yeah. That's all I've got. If anybody else has any questions for me, I'm on this phone pretty much all the time.
All right, we'll send them to you.
Okay.
Chris. Okay.
Thank you.
You have a good day.
Thanks, you too. Bye-bye.
Bye now.